Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 higher tier from 2024. This paper 2 is 1 hour 15 minutes long and it has 6 questions. And the 3 main topics that is being tested on is forces, waves and magnetism. Let's have a look at question number 1. Question number 1 is on the topic on waves. Now, before I start, this question number 1 and in fact question number 2 is question number 6 and 7 in the foundation tier. So if you're doing the or revising for the foundation tier, question 1 and 2 will be useful because it's exactly the same questions. So let's start. Figure 1, or a teacher demonstrated how the frequency of a wave on a string affects the wavelength of a wave. Figure 1 shows the equipment used. Here you can see in figure 1 you've got a signal generator which is over here and which is connected to a vibration generator over here, and then to the vibration generator is attached a string which on the other end is attached are the masses. Now this string is pulled down across the pulley and there's a tension that's created, and in between there's a movable wooden bridge. When you switch on the signal generator, or you can actually select a frequency, in this case it shows 45 Hertz, that will cause the vibration generator to move up and down according to that frequency of 45 Hertz. And when that is moving, the string also moves, causing a wave to be generated on the string. So the frequency of the signal generator is adjusted so that the wave shown in figure 1 is seen. So there's 45 Hertz is the frequency. And from there to here is one wavelength or one wave. At this frequency, the string vibrates between the two positions shown in figure 1. Describe a method the teacher could use to investigate how the frequency of the wave affects the wavelength for 4 marks. So how would a teacher use the equipment to investigate how the frequency of the wave affects the wavelength? So as you can see, there's a frequency of 45 Hertz. At 45 Hertz, it's producing a wavelength or one wave. And the wavelength can be measured using a ruler which is at the bottom over here. So if I say that's about from 0 centimeters, so let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say that's 80 centimeters. What will happen to the wavelength if I increase or decrease the frequency? Well, if I go down by 5 or 10, so let's increase it by 5 from 45 Hertz to 55 Hertz. What happens? So the teacher would actually increase the frequency in the signal generator and then wait for the new wave to be produced, right? And then measure the wavelength. Now for that you need to be able to move the wooden bridge, right? So you need to adjust the wooden bridge so that you're only seeing one wave, and the wave that you should be seeing is what you call a standing wave. It will appear as if it's actually not moving. So here's the answer that you could write. Use the signal generator to adjust the frequency. Right? First of all, you start by adjusting the frequency in the signal generator. Keep the number of masses the same. So the masses that is hanging on the end, which is over here, you want to keep the tension the same. Move the wooden bridge. Observe a steady stationary wave pattern. Use the meter rule to measure the wavelength. Repeat using different values of frequency. Repeat for different stationary waves. So every single time you adjust the frequency, you move the wooden bridge so that you're only seeing one wave pattern, and it should be a stationary wave pattern. And then you measure the wavelength and you repeat it again. Next question. Use the physics equation sheet to answer questions 1.2 and 1.3. Which equation links frequency, wavelength, and wave speed? So if you look for that, the equation is V equals F lambda, which is the third equation. The wave on the string has a frequency of 45 Hertz, right? And the wave speed is 35.1. Calculate the wavelength. So V equals F lambda. So V is 35.1 equals 45 multiplied by the wavelength. So wavelength equals 35.1 divided by 45, and that should give me 0.78 meters. 0.78 meters. That brings us to the end of question number 1. I will see you in question number 2.